Number 8 says find all possible values of the inverse sine of the square root of 3 over 2. Now I mentioned this in the previous problem. Remember that on your unit circle, your x and y coordinates are the same thing as the cosine of your angle and the sine of your angle. So when you see inverse sine of square root of 3 over 2, you're asking yourself, where does the sine of your angle equal the square root of 3 over 2? Now thankfully you'll be looking at your unit circle for this, and you're going to find two different places where you're going to get the sine of, or the sine of an angle equals the square root of 2. In radians, you're going to find out that one of those places is at pi over 3, and the other place would be at 2 pi over 3. I'll get to degrees in a moment. So this one says find all possible. You looked on the unit circle, you find exactly 2. But remember, there's an infinite number of coterminal angles there, which means you can go to that point and then add additional circles to it or subtract circles from it and end up at the same exact point. In order to write that as part of a formula, we're going to say plus or minus 2 pi, a full circle, so it can either add another full circle or go backwards another full circle, times n, where n is just the number of times you're doing it. Same thing with 2 pi over 3. So plus or minus 2 pi times n. So again, you're going to that angle measure and continuing to go on in full circles or going backwards full circles. In degrees, pi over 3 is 60 degrees. 2 pi over 3 is 120 degrees. Now just like with radians, you can go additional full circles. So you can either add 360 or subtract 360. And we're going to multiply by n because we can do it as many times as we want. Same thing with 120. So we'll say plus or minus 360 times n.